All right, I think we should get started. So thank you. Welcome everyone to the first inaugural Denver Data Fusion Meetup. Very excited to be here. Yeah. Yes, and I first wanted to say thank you very much to our sponsors, who is Recode, Code Talent. I'm sorry, Code Talent, and who gave us this lovely space, and CoreLogics, I believe, who's subsidizing the wonderful meal you're just eating. And we have Riley here from Code Talent that maybe you could say a few words. Yeah.
That's easy on me, but I've been helping to hire folks, all different types of engineers, through operations types folks for Denver startups for the past about 10 years. Hotel, we first started with some popular names around here, like Ibotta, SendGrid, Proxy, and but now we're under Sacramento, hiring teams. So if anyone is looking for work or is looking to hire, I'm happy to talk about how we work and what we do and what makes us different. But yeah, enjoy the space. So,
Yes,
thanks.
thank you so much again for having us. Yeah, organizing these meetups is basically a function. You got to find the space, and then everything else comes together. So wouldn't happen without the space. Thank you. All right. So with that, I'm going to start by basically giving a brief introduction to Data Fusion. At least I think it's brief. Hopefully, this won't bore you if you've seen some versions before. I do have new slides. My name is Andrew Lamb. I'm a staff engineer at InfluxData. We build time series database, and I'm also the Data Fusion PMC chair. And I've worked quite a lot on various other Apache Software Foundation projects. So Apache Software Data Fusion, which we'll talk about, is it's a top-level Apache Software Foundation project. There's the website, and I'm going to start with basically describing what it is. And of course, like all good presentations, to describe what it is, you have to describe what it's not. And so what it's not is is an entire database system. So a lot of times, like, you build your application, and then you have a database system that's made some particular choice of file format and how it's going to store the data, and the query language you're going to use, and sort of the operational characteristics. And oftentimes that combination is good, right? So there's lots of examples of existing database systems. Speak louder. There's lots of examples of existing database systems, right? Like ClickHouse, DuckDB, Postgres, whatever. But and if those trade-offs work well for you, right, whatever the designers of those systems chose, those are good choices. Or if you ever want to customize more carefully, or more deeply, like that's where Data Fusion sits. So instead of, if you like your application, then you have the database. Instead, if you want to have much more control and build a data intensive application, maybe a database or some other system that I have a bunch of examples later on in the talk, that's where Data Fusion really is. So it's designed so that, yes, it comes out of the box with all the features you would want, but it's really designed to be able to extend it. And so if you just want to run SQL on files, there's probably other systems that are better for that. But if you want to like really get down to the guts and customize how it's going to work, or carefully optimize how it's going to interact with storage or file systems or whatever, that's what Data Fusion is for, right? So it's basically for people building these data intensive systems. So previously, right, actually this is Andrew Madsen made a great talk or a blog post about this. Previously, like, why is Data Fusion, like, why are people here, why are we talking about Data Fusion? It's because previously, if you wanted to build one of these data intensive systems, you'd either have to embed a complete database, like one of these existing, DuckDB or something, and you can, which has a well understood interface. But if you want to go outside that interface, it's very, very hard. Like, you can fork those systems and modify them, but keeping up is very, very challenging. Also, you can try to build a query engine from scratch, which I'm somewhat biased, but I've done it twice now, and it's a very expensive proposition. So what it basically means is, now, we have several people actually with examples of customers or people who now use Data Fusion who actually took existing system. They actually tried to fork DuckDB specifically, and they built their system on top of some forked version of DuckDB, and eventually they moved to Data Fusion, mostly because not because the performance wasn't good enough, but because every time DuckDB changed stuff internally, right, the system wasn't set up to allow them to have their system modified. And so every time the upgrades was just a pain. That's not to say Data Fusion upgrades are like perfect. I know some people in this room might have had some pain, but compared to like dealing with a fork of a monolithic code base, I think it's much better. And so of course you can now do Data Fusion. All right, so I don't want to dump on that too much. So what does Data Fusion have? There's a feature list. I'm definitely not going to read this, but like, this is the kind of thing, if you look into the number of features and the types of things you need in a modern data system, it's a lot, right? This is part of why it takes so long to build one of these things, because you need all the fast vectorized OLAP engine, whatever that we'll talk about. And then there's a lot, it integrates with the ecosystem. It's Substrate, it has SQL, right? Actually, SQL itself is a large amount of implementation. It's got the query optimizer, it's got execution stuff. We talk all about this stuff. I will tell you about this for hours, but the point of this slide is mostly that it is a wall of text and it's a lot of work, right? So Datafusion has a lot of these things and you can extend it anywhere. The other thing I think that's very cool about Datafusion recently is that the third-party ecosystem, right? It's one thing to say it's very extensible. It's another thing to have examples of how it's actually used. So there's actually quite a lot of functionality out there that's not part of the core Datafusion project or crates themselves, but instead is built using the extensibility. And here's a bunch of examples. I'll highlight a few briefly, but I think this also shows a more modern approach to building these data-centric systems, is that you no longer sort of just pick whatever particular choices that a vendor has already picked. Instead, you pick and choose the different combination of pieces that you want, and you sort of assemble a data system that's bespoke and just fits your needs. So, right, if you want to do distributed stuff, distributed queries, there's a lot of interest in that from people in this room, I know. But there's also people who have made a whole set of providers for connecting with other types of databases, right, like Postgres or SQL or whatever. There's also, if you want to do semi-structured data, right, that's not built in directly into Datafusion, instead it's done through extension packages. So if you want to use JSON specifically, or this new data type called variant, which is a binary version of it, it's faster. Geospatial, right, there's a package to do that. You can integrate with Duck Lake. You can, there's a set of functions that let you basically write a federated database, which effectively lets you push queries, right? You write a query, Datafusion will push queries down into other databases for you. Integration with tracing stuff. So it's basically like, you can just imagine like Lego pieces, right? You want whatever in your database, you just kind of put them together. So that's basically the composability part. Another thing is at the end of the day, the core features of Datafusion is the performance actually does matter a lot. Basically, it's the core reason why people use this. And we've been getting faster. This is like our own benchmark, right? It's comparing ourselves. I'm quite proud of this, especially that drop in 54. We spent quite a long time. By the way, thank you, Dan Harris, who's buddy Daniel Harris, did a bunch of this work too. But anyway, so the point is, over time, the performance is increasing, and this is due in no large part to the amount of effort of that ecosystem, and it is continuing, right, even up to the last up to June. So in particular, actually, this is real fun. I went and checked. ClickBench is my favorite whipping boy. We spent a lot of time optimizing this particular benchmark. This is a filter and aggregation heavy query. It actually turns out in our most recent version, Datafusion is actually at the top for some ridiculous machine. I'm not sure what CAG40XL metal is, but it's big, but it actually we're fastest on that one, which I'm very excited. And a more reasonable machine, right? A more like 32 core, or 8 core. I think those are 32 core, 64 gig machines. We're still basic, we're very close to DuckDB, and we're still fast in some of those. So the point is, like, you get a very, very fast query engine, but you get all this extensibility. Is basically the point. I'm very pleased that we're up there now. So what is my aspiration for Datafusion? It's basically that it becomes the LLVM for databases. I know it's a super geeky analogy, but I love it, so I keep telling people about it. And the reason, like, what is LLVM? It's the same. If you want to build I don't know how I want to date myself, but once upon a time, GCC was like the only game in town, right? And there wasn't a lot of innovation in programming languages. And part of the reason was because the amount of effort required to build a whole new tool chain was very substantial. You build a compiler, but then you also have to build the code generator and the debugger and nowadays like the language server or whatever. But LLVM came along and it basically took all the common pieces across different tool chains, right? The code generator, the fast optimizers, all the optimizer passes, all the stuff that's common, and it put into a library that could be reused. And I think not only does that reduce the amount of effort required to build new languages, language tool chains, what it really did was it created a giant explosion in innovation. Right? So the reason you see languages like Rust, Julia, and basically any language that's come out in the last 10 years, they all build on top of LLVM. And the reason is because LLVM basically took all the common pieces. They gathered all the people were able to rally around that, focus on the common, non-differentiating but important technology, and instead spend most of their time building like what was really important. So, in my mind, obviously, what I want is I want Datafusion to do that. I think we're well on our way these days. So the idea is, if you're going to go build one of these modern analytic systems, rather than you spending lots of time reinventing vectorized kernels and all like the low level SQL stuff, which as I said, like we now know how to do it. We've been doing it for 30 years, but it's still very expensive. You can go look at how complicated Datafusion is to get a sense. But instead, basically use Datafusion. Hopefully you contribute back, but you realistically spend most of your engineering time building the features and stuff that are important for adding value to your product. So that's what I mean. All right. So with that being said, I will now do a little more propaganda about how big the company community is and that sort of stuff. And I'll tell you a bunch of use cases, and then we'll move on to some other interesting talks. So I always love every time I come do one of these talks, I basically update the slide, and every time the numbers get bigger, which is very cool. So as of this morning, or maybe yesterday when I did this, we had over 1,000 distinct contributors. It's probably realistic more like 900, given how the Git history is done. But like that's quite a lot of individuals who've contributed. And that's mostly, by the way, before AI generated stuff. It's accelerating before, but Datafusion's been around, I think, 8 years. We currently have 23 members on the PMC, which is the sort of governance committee, 60 people who have commit rights to the repository, and we had in our last release 139 distinct contributors. Now, of course, like most open source projects, there's a huge power law distribution, and most of those contributors contribute one thing, but that number has continued to grow over time, and I'm very, very proud of that too. It's not just one company; it's really a community endeavor. Yeah, so obviously part of why I run around here is to like convince people to come help work on it. But nowadays, maybe I don't have to plead quite as hard because there's now more people contributing than ever. Right? Again, perhaps because of AI tools, but it's kind of fun to find places that people are actually interested and willing to help talk to you about how databases work and help you understand how it works, rather than like, it's one thing to be like, hey, here's our code that you can look at, but like we're not really interested in like working with you to contribute stuff. Versus I've always found the Datafusion community very welcoming and wanting to help people. And of course, we don't just need code, especially now with AI, we need all the other stuff. All right, so anyways, please join us. Another thing I want to talk about briefly was the ASF. So what is the Apache Software Foundation? That's like, I think if you're in it, it's kind of obvious, but if you're not in it, it's kind of like this weird governance thing, right? Like, so what the ASF is not some foundation that then funds development, right? Like they don't pay anyone to develop software. Instead, this thing is basically an umbrella organization that helps open source projects apply best practice governance, which sounds all very boring, but basically what it means is it gives you a home as an open source project to live and grow, and it helps you figure out how to manage yourself. And I think the primary benefit of Datafusion being part of Apache is that it gives a stable foundation, right? Like if you want to, basically tell you you're going to go build some product or some cool data product thing on top of our library, right? But you got to have a lot of confidence that that's not like someone's not going to change the license terms on you, for example, right? And that there's some story for the long-term maintenance, and that you can somehow get other people involved. And so I think between all the stuff that Apache does, the fact that we're part of the Apache Software Foundation, lets you have a predictable, stable foundation, right? Like VC funding cycles are not, individuals will come and go for sure, but the overall project has a longer term arc. All right, so that's like the high level spiel, and now I'll talk more about the use cases. It used to be actually kind of hard to find example use cases for Datafusion, like specific example use cases, but it's no longer the case. So the first use case, which is probably obvious, actually a lot of people build specialized databases, right? Like so, Datafusion is a classic relational database, basically, or at least it's a query engine. But a lot of people then use that to build specialized engines. So there's a lot of people build time series and observability systems on top of it. We've had people build informatics systems. We had someone just the other day talking at the Datafusion community showcase, I think we called it. He was talking about how he's basically using the query engine to query like geospatial scientific weather data. But like he presents that as a two-dimensional table and then uses SQL to query it. But he was doing crazy stuff. And there's a bunch of streaming engines, a whole bunch more. So you want to build a new database engine, a lot of people have done that with Datafusion. I think also interesting, this is not something I fully appreciated when we started, and I'll bet a bunch of you in this room have done this. It's like a lot of companies, when you get to a big size, can afford to have basically customized data infrastructure for your particular data needs. Right? And those tools are built up over time with various different technologies. So I think a lot of people will use Datafusion as part of their internal data platform, either greenfield projects, or they'll use it to start replacing existing features. So there's a whole bunch of people, I made argue whether the CoreLogix falls into this category, but there's a bunch of people basically use this as part of an internal data platform, maybe not directly part of their product. Um, but definitely running in the background. Yeah, actually something else, this is like a related version. I was actually just talking to you about this one, is the one of the funnel IO people were describing this is like there's a lot of data platforms around. They have a lot of different histories and different technology stacks, right? Some older than others. And I think sometimes when people are trying to update them, apparently Datafusion has been quite good because you don't have to replace the whole thing at once, because it's so flexible. Like the funnel IO guys were basically talking about, we're not going to replace the whole custom query engine thing up to begin, right? They'll do it eventually, but they started with like just scanning files and applying predicates. Right, then they're going to move on to aggregates, and then they were going to move on, and eventually they had like their own sort of customized functionality they needed to do, but to reduce the risk of deploying that change, they weren't rewriting it wholesale; they were going to incrementally do it. Which and they said explicitly that some of the fact that you had such control with Datafusion let them do that. We've seen Datafusion used a lot for data federation engines like Spice AI. There's other examples. Ren AI, Datadog has a lot of stuff, including a federation engine. The federation engine, right? You want to run SQL, but then the underlying data might be in various other systems, either data SQL systems or sometimes even non-SQL systems. I was actually talking, I think, to the 7AI folks recently, and they have some like SQL interface that lets you like go query basically logs and event information across all sorts of different like data stores where they are. So you have one interface, you don't move your data, but you can effectively push the predicates and stuff down. So that's another common use case for Datafusion. Another common, at least one person in this room very focused on this is accelerators for Apache Spark. Apache Spark is a very widely used data infrastructure platform, piece of software. It's all written in JVM, and people have realized if you rewrite it with native code, you can get about a 2x performance improvement. And so for people who have large scales, 2 to 4x, performance improvement translates directly into large amounts of dollar savings. So that's why I have the interest in several examples in Datafusion Comet and also Auron, which is another Apache project, are basically swapping out the execution engine of Spark for one built on top of the Datafusion pieces. Another interesting thing is actually when you're implementing table formats. I don't know if you're familiar with this. This is sort of my pet bugaboo is table format is sort of metadata layer on top of a bunch of files that lets you sort of treat a bunch of files in object store as a coherent table and add transactional semantics on them. But a lot of times the specs will include functions that look a lot like data processing, like merging files together and deleting stuff and computing predicates. But anyway, so the point is, while it might be a format to actually implement the format and the features people expect, you need a lot of it looks like a query engine. So in fact, I think last time I checked, all 3 major table formats, the Rust implementations use Datafusion to do that query piece of it. In addition to letting people use query data using that format internally, they're using Datafusion. We've also seen Datafusion used in academic research, perhaps not as relevant to people in this room, but it's kind of fun to see modern database researchers also writing cool stuff. I'm especially proud of this AnyBlocks one. This came out of the TU Munich research labs. And those guys are like hardcore C++ database people. So the fact that some of their grad students are like writing stuff with Datafusion is pretty exciting. There's actually, I think there's at least one of these other ones came out of TM as well. Maybe PhD theses, but definitely master's theses so far. All right. The other interesting thing for a long time, people use Datafusion for data visualization tools, which doesn't sound like an obvious candidate, but it turns out a lot of times to drive a data visualization engine, it often involves like summarizing lots of underlying data quickly into a format to then visualize. And so there's been a whole bunch of examples of this. Specifically, Vega Fusion is one of them for this Vega visualization language, and there's several other examples now where basically people are betting a query engine in what's effectively a visualizer in order to quickly drive it. Actually, it's also like the original BI, a lot of BI tools from like the last 20 years. Effectively, it had custom query engines like Click and it's not Click. Is it Click? I can't remember what their product was called. But anyway, that's it. I guess the other final thing you could. This is perhaps an old one when I used to be struggling a little bit more for use cases, but also when you're implementing file formats, it turns out you often need stuff that looks like a query engine, like you're writing data to a file, you got to sort it typically, and then also maybe sometimes you compute min-max values for statistics, that kind of stuff. So the Lance file format uses Datafusion for that. On the final one, yeah, here go the DBT example. So other thing that I never would have guessed people use Datafusion for is, because I've been talking about execution, right? You're running the SQL and stuff. Actually, some people use it just for the front end, for like just the SQL parsing and analysis piece. So in this case, this was the SDF use case, which has subsequently been bought by, I think actually we're going to hear more about this later on. But basically what they did was they were analyzing large corpuses of SQL queries, right? They're basically trying to do data flow analysis between them to try to figure out, if you run the sequence of 20 queries, this output column, where did it come from? Right? Did it, for example, have person identifiable information that contributed to its output, that kind of stuff? And so just doing that analysis without having to rebuild the whole SQL AST was very valuable. Yeah, and I haven't updated this. That should also now say 5 trip. So anyway, thank you very much. Hopefully that was interesting. I think now we've got Brent up next.